Dear students, I am P. Madara, lecturer in physics, in continuation of our video lectures, that is part 2 Vsaq'S 11th class. We'll continue now. Here, part 2 Vsaq'S. Now, from all chapters, that is now Newton's laws of motion. In this Newton's laws of motion, here, first question is, a bomb at rest explodes into two pieces. Must travel in opposite direction. Now if this is a bomb at rest, explodes into two pieces, must travel in opposite direction. Now this is based on conservation of momentum. Suppose one bomb is there, it is being exploded. This is initially its momentum is 0. Now suppose m1, that is total mass, m into u is equal to m1 v1 plus m2 v2. Initially u0, initial momentum is 0. So here m1 v1 is equal to m2 v2. So here m1 v1 is equal to minus m2 v2. So both will be in opposite, going in opposite direction. So it is based on law of conservation of linear momentum. Okay. When a bomb at rest explodes and must travel in opposite directions, means here initial at rest, initial velocity 0. This is mu into u, being split up into two parts, m1, m2. This is m. So here m1 v1 is equal to minus m2 v2, but they must go in opposite direction. Okay, this is the first question. And next question is here, can the coefficient of friction be greater than 1? Can the coefficient of friction greater than 1? So here the coefficient of friction can be greater than 1. Yes, answer is yes. Answer yes. Now here it is for a heavily polished surface, because of frictional force increases due to increase of the adhesive forces of the between the molecules. Or example you can take between copper and copper, it is 1.6. It is due to a heavily polished surface, the frictional force increases due to increase in adhesive force, between the molecules. Okay, example, if you take copper is 1.6, you can take like rare case, it is 1.6. The second question. Okay. Next question. See, regarding this previous lecture, while doing this atomic mass, unified mass, I took this correction is there, little correction here. While doing this, on that is unified mass, while defining, it is AMU, atomic mass unit or unified mass. 1/12th of the mass of the carbon atom, part 1 lecture, that is 1/12th of the mass of the carbon atom. So carbon atom has that is atomic weight, that is carbon 12 grams you have got. 1/12th of the mass of the, this Avogadro number 6.03 to 10 to the power of 23 is there. I wrote only 2, 3. So make a correction here. Then answer is I wrote correct only. It is 10 to the power of minus 27 kg. This correction you take it out. Okay. And one more question like correction in the previous part 1. One more you have here. While defining this percentage error in kinetic energy. Kinetic energy is equal to half mv square we wrote. That is percentage change in energy delta E by E is equal to delta M by M plus delta 2 into delta V by V you should write. That is into 100. Percentage error means into 100 only, like into 100, that is understood. Okay, here delta M by M, how much percentage you got here? Delta M by M is 2% and delta V by E is 3%. So 2 plus 6, 8% you got. This coming to beyond the board it and the answer, so you could not notice this. So 2 plus 2, 8% is the answer. Okay. Please note this correction in the previous lectures. Problem I wrote correct only, answer also given. This I took it as by mistake it happened. 10 to the power of 23 it should be. Okay. Thank you. Next, coming back again. Coming back here in this what happens to the coefficient of friction? Third question. What happens to coefficient of friction if weight of the body is doubled? See, what happens to coefficient of friction if weight of the body is doubled? Now in this, frictional force directly proportional to normal reaction. Mu is equal to F by N. If weight N doubled, F also doubled. Mu remains constant. So therefore, mu remains the same. Mu is independent of weight of the body. Okay. Mu is independent of the weight of the body. Okay. This is the answer for this. What happens to coefficient of friction if weight of the body is doubled means here F is directly proportional. Mu is equal to F by N. Weight means normal weight, normal reaction like. This is doubled, F also doubled. Cancel. So mu remains constant. Mu is independent of the weight of the body. Next question. Next question is why does, fourth question, why does the car with flattened tires stop sooner than the one with inflated tire. See, in case of flattened tire, what happens? Rolling friction is greater. So in case of flattened tire, answer, flattened tire, rolling friction is greater. Area of contact is more. And then area of contact is more, and deformation getting more. Okay, flattened tire, rolling friction is greater, area of contact is more, and also deformation is greater. So area of contact. Therefore, car with flattened tire stops sooner. Okay, this is a question you have got. Now there are some simple questions. Why RC has to pull harder during the start of the motion than later? Like oral question only. Static friction greater than kinetic friction. And then during impulse, change in momentum also you have one questions. These are some of the questions you got. Again, we'll do it. Now next, work per energy. Work per energy chapter. State the conditions under which force does no work. Force does no work. Now you know W is equal to Fs cos theta. First one, when F and S are perpendicular. Theta 90 degrees, cos 90 is 0. Work done is 0. Second case, if displacement is 0, then also work done is 0. Third one, if force is 0, then also work done is 0. So these are the conditions. Theta 90 degrees, work done 0. Displacement 0, work done 0. Force 0, work done 0. Next question. State the relation between kinetic energy and momentum of a body. State the relation between kinetic energy and momentum of a body. Kinetic energy and momentum of a body. Now in this, the kinetic energy is given by half mv square. We got half mv square here. Now in this half mv square, here, this kinetic energy can also be written as P square by 2m. Kinetic energy written as P square by 2m. So that is the relation you got here. Kinetic energy is equal to, if you write here, half mv square, if you multiply and divide with m square v square by 2m. This is P is equal to mv. It is P square by 2m. The relation is kinetic energy is equal to P square by 2m. This is the relation. Kinetic energy is equal to P square by 2m is the relation. Okay. Now next you got one important here. The few questions are there, like you are asked to calculate the sign of work done. Sign of work done means positive or negative. One technique I'll tell you to answer the all questions related to the work done positive or negative. Suppose W is equal to Fs cos theta. If theta is 0 degrees, if F and S are in same direction, work done is positive. Work done is positive. If F and S are in opposite direction, theta 180, work done is negative. This you concept you remember. Any question you can answer. Suppose for example one question I will do it. Now one question like work done by a man. Say work done, this is already written, work done. Now one question I will do it. For example like you have to state the sign of work done. State sign of work done. In this work done by a man. Work done by a man. In lifting a bucket of bucket out of a well by means of a rope tied to the bucket. Second case, work done by gravitational force in the above case. Work done by gravitational force in above case. Now a man is there. You can observe here, man is there. He is lifting bucket water from this well here. Okay, this is well like. Now in this case, what is happening here? Work done here, lifting bucket in upward direction, force upward direction, displacements also in upward direction. F and S are in same direction. F and S are in same direction. Same direction means I told already F work done is positive. Second case, work done by gravitational force in the above case. See, gravitational force acting in downward direction and the displacement is in upward direction. In this case, second case, F and S are in opposite direction. Opposite direction means what? Work done is negative. Opposite direction. So this concept you remember, easy to do any sort of problem. You see, work force and displacement same direction, work done positive. Opposite direction negative. That's all. Divide based on this, you can answer many questions. Now coming back again here, which physical quantity? Next question, which physical quantity Which physical quantity remains constant? A. Elastic collision. B. Inelastic collision. You know, elastic collision means both momentum and kinetic energy are constant. Okay, A answer. In elastic collision, both momentum and kinetic energy is constant. In inelastic collision, only momentum is constant. Momentum is constant. Momentum, both momentum and kinetic energy. Conserved also says, some book says conserved. Anything, both are same only. It is conservation also. Okay. This is another important question. Next, which physical quantity remains constant? Elastic collision. In elastic collision, both momentum and kinetic energy constant. In elastic collision, only momentum is constant. Now next, a body falling freely falling, body is freely falling from a certain height h, and then after striking a smooth floor, rebounds to a height of h by 2. Then find coefficient of restitution. Now E is equal to under root h2 by h1 you can take. This is h2 is rebounding height h. So it is 1 by root 2 is the answer. 1 by root 2 is the answer for this. Okay. We can simplify also. Divide and multiply with root 2 means root 2 into root 2 you can take. Divide and multiply. That will be E is equal to, we'll get this as root 2 by 2. 1.414 by 2. That comes out to 0.707. You can leave this answer here or you can do up to there. E is equal to 0.707. Okay. These are some of the questions we have got. And one more important question, though it is a little SAQ type, but the concept is very important. Just I'll do that question. So here, a lorry and a car, many times asked here, a lorry and a car moving with the same momentum are brought to rest are brought to rest by the application of brakes. By the application of brakes. Okay, by the application of brakes. Now, which provide equal retarding forces. Which of them will come to rest? Which of them will come to rest? Will come to rest in shorter time and then which will come to rest in less distance? Come to rest in less distance. Two questions are there. So here momentum. You know momentum is what? Force into time can be taken as momentum. Okay. Same force, same momentum. Actually, momentum is force is equal to change in momentum also you can take, but it is brought to rest now. One more velocity becomes 0. So I am writing m into v. So, okay, m into u or m into v, no problem. So here, so both are same means here T1 is equal to T2. That means what? Both will come to rest. Both will come to rest at same time. This is first answer. A. Which will provide equal, which of them will come to rest? No, this is A. This is B. Which will come to rest in less distance? Now you know, work energy theorem you apply. W is equal to delta K. So force into distance is equal to, instead of kinetic energy, we will write one velocity becoming 0. So here F and P are same. F and P are same. So S is inversely proportional to M. S is inversely proportional to M means what here? This here. So lorry will have more mass, it covers less distance. So lorry having more mass, it covers less distance. Okay. So these are some of the important questions. Though it is given sometimes Vsaq'S like that. A little more question, but a objective also important concept is most important concept in this PART1 chapter. This problem, this question. So I did this here. Okay. First case, which will provide equal, which will come to rest in a shorter time, means time is same. Second case, I am using work energy theorem. W is equal to delta K. I wrote F into S is equal to P square by 2m. Kinetic energy P square by 2m you can write. S is inversely proportional to M. So therefore, what you got? The lorry having more mass, it covers less distance. Car with less mass cover more distance. Okay. So these are some of the questions. I will be continuing again next lecture also. We have like part 2 completed now. Okay. Thank you.